So now we're going to talk about what exactly does it mean to establish an identity. Okay, so let's read through the bullet points here. It says the directions to the remaining problems in this section read establish the identity, blah, blah, blah. Okay, so then you'll just be given some equation that is an identity. Okay, the word established can be interchanged with verify or prove. Okay, so the way you want to think about this whole thing of this whole idea of establishing an identity, you're verifying it. You're proving that the statement is an identity. Okay, this is accomplished by starting with one side of the given equation and using appropriate basic identities in algebraic manipulations, arriving at the other side. Okay, this is very important. Okay, this is basically what you're going to do. Okay, so you are going to start with one side of the equation and use identities that you already know. Okay, you can't use an identity that you don't know yet. Okay, you're going to use basic identities combined with algebraic manipulations, things like we did in example 1, and you're going to work your way until you get to the other side of the equation. Okay, in the next bullet point, so we've done this one, now we're here. Do not try to establish an identity by treating it as an equation, meaning we cannot add, subtract, multiply, or divide both sides of by the same expression because we do not know if the sides are equal. That's what we're trying to prove, okay? So you can't treat this as a regular old equation, okay? No adding the same thing to both sides, no subtracting the same thing to both sides, no dividing both sides by the same quantity or multiplying by the same thing, okay? Can't do it, okay? You're basically starting with one side and trying to achieve the other, okay? Another biggie, okay? You cannot use a graphing calculator to establish an identity, okay? Although a graphing calculator can be used to provide evidence of an identity, so there is kind of a way to check on the graphing calculator to see if it's an identity or not, you are going to have to do this algebraically, okay, to get full credit, okay? You're going to have to do this through the algebra, okay? All right, so here are some tips for establishing an identity, okay? The first one, very important, always start with the more complicated side, okay? If you've got a really complicated side and you've got something that's not complicated at all, you can actually do more. You can work with or manipulate the complicated side. So start there, okay? Then another thing, you may want to use an expression, or sorry, it says apply one or more of the following tricks, okay? So use an established trigonometric identity to transform an expression into an equivalent one, okay? So again, use some trig identity that you already know. So for example, in this little bullet point here, it says, use the Pythagorean identities to transform between sine squared x and cosine squared x, okay? So for example, we know that sine squared theta plus cosine squared theta is equal to 1, okay? So like you can manipulate this. If you subtracted cosine squared theta from both sides, you know, if you see sine squared theta in your identity, you can replace it with 1 minus the cosine squared of theta, okay? So you can do things like that, okay? Remember, there are 3 Pythagorean identities, not just one, okay? Remember, the others are, here, I'll write them all out. We know sine squared theta plus cosine squared theta is equal to 1, okay? We know that tangent squared theta plus 1 is equal to secant squared theta. And we know that cotangent squared theta plus 1 is equal to the cosecant squared of theta, okay? So make use of those Pythagorean identities, okay? All right, another thing you can do, and these guys are more of the things we saw in example 1, okay, as far as algebraic manipulation, try multiplying and simplifying, try factoring and simplifying, try combining terms into a single fraction, and remember, in order to do that, you have to get a common denominator. Another thing that's really helpful, especially if you're just, kind of clueless and can't figure out how to get this thing to work, express everything in terms of sine and cosine. Okay, that usually helps a lot if you get stuck. Okay, another thing you can do is multiply by the conjugate. Okay, so there's lots and lots of things you can try to do to get these things to work. Okay, let's jump down here. It says always keep the goal in mind. As you manipulate one side of the expression, keep in mind the form of the expression on the other side. What am I trying to get to? Okay. There can be more than one way to verify an identity. And I'm going to show you that when we verify our first identity. Okay. There can be more than one way to do this. Okay. And that's another reason this gets tricky. Okay. The last piece of advice is to practice. Practice, 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 practice. Okay. This can be a challenging topic because it's kind of maybe one of your first introductions to mathematical proof. You are proving something. And sometimes, and even me, I've done this for years, and sometimes I'll be verifying an identity and I think I'm doing it completely correct. And I realize, pretty far in that I've just hit a roadblock. I'm stuck. I've got to start completely over and try a different method. Okay. But the more you practice, the more comfortable you will get with this. Okay. And I'm going to give you plenty of examples, not through just the videos, but I'll also give you a little worksheet that you can practice, and I'll have the solutions written up for you as well. Okay. But make sure you keep these tips in mind.